tried to make some adjustments about that. Is that still true? Is anyone getting the audio? I have it dialed back a little bit. Yeah, I was switching it. I'll turn it up a little bit. Someone described it as heavy metal in the last class. Yeah, I would assume it's just a network error, so all I can say is we'll try our best, and we'll try to put some text on the screen for you to read in case the audio continues to be bad. I was trying to change the room a little bit so that the sound isn't echoing quite as much, but it's still not the best. So I'll be open the door. I might be able to at least cut down the echo a little bit. Just doing massive samples today to teach the concept, so let me just start running mode for it now. So which we used last week and we've used earlier in the semester several times. Actually already done most of the second project in the rock scissor paper file. Statements to say So I know people are having different experiences. I can put a note here, so. Unfortunately, that's the best I have to offer. I've manipulated MySpace and I've tested it with my wife in the next room, and she can hear me over Twitch, so it's network issues of some sort and out of my control. Yes, several people are having audio issues. For some people, if I back off the gain a little bit, it has helped, but not for everybody. I'm seeing lag on Twitch. I think it's just probably we're competing with the world right now. So that's the best I can do, sorry. Let me turn on my sound and listen to it for a sec. Yeah, it's pretty rough. To cushion it a little bit. I think part of the problem is my fan. Part of the problem seems to be the network. Let me just do a quick audio test on it again. Okay, so on my machine, I can make out the words that I'm using. It's not great, but I can make out my voice. We're going to take a walk, and I'll try another room. Unfortunately, if this is an ongoing problem, it's not a sustainable way to do the class, and I don't have any other way to do this, but I'm looking for a quieter room. Let's see if this room is any better. This room might be better because there's a couch in here. Less places for the sound to echo. Oh, hold on. Need my lap cushion. Okay, so let's try it this way and see if it's any quieter. Hopefully. Most of what you need to see will be on the screen, so hopefully if you're having audio issues, you can just turn off the audio and just watch the coding sample. And it's not ideal, but we'll just do the best that we can. But maybe this has cleaned it up for some people. I'm actually going to test real quick and see. Yeah, it's still not the greatest, but it's the best I can do. short of the college providing me with the studio. Okay, so yeah, I think it's a little bit better. I keep playing with the gain. Unfortunately, right now you can't like buy things from Amazon because they won't ship it to you for several weeks because I guess toilet paper. So we'll just go with this. Alright, so we've done this example before, but this loop will cause the menu to print, the prompt to print, and then ask them to type in a choice forever. I'll just show you real quick that that's the case. So this is the part where you don't really need to do this just yet. I'll just show you. So there's there's a missing line break. But there's the menu, there's the prompt. If I type a 1, it'll do the menu and the prompt again. If I type a 2, if I type a 3, if I type a 4, if I type a 0. So it's just going to do this forever and ever and ever and ever and ever. Control C, if you did that, by the way, to kill it. That's Control C. This needs a new line character. Probably 2 is going to look better. Okay, so we need some way to manually break this loop for starters. So let's deal with that right off the bat. So this is where we use decision making, because what we want to do is say, well, if they chose a 0, we want to quit, but if they chose something else, we want to branch or do something different, take a different action. So I'm going to do it quickly with an if, and then I'm going to swap that out for a switch. So the way we would have done this last week, we would have said if the choice equals 0, break. And maybe we'll print a message first, like, thanks for playing. If the choice was 0, thanks for playing. Else if the choice was 1, I'm just going to put a comma in here for now because we have nowhere to go with this yet. There's no number guessing game and there's no rock, scissors, paper game. But if the choice is 1, then we'd go play rock, scissors, paper. Else if the choice was 2, go play number guesser. And then often what we'll do is have a fallback, which we'd call an else part. This else means that nothing else matched. So they didn't type a 0 and find a match. They didn't type a 1 and found a match. They didn't type a 2, so they typed something else. In which case we usually say something like, is not a valid choice. And then I'll actually print the choice back out for them just to show them, hey, you typed 42 as your choice, and that's not a valid choice. So this is anything else. So that's one way to set up the branching statement. I handled this part first, where I am manually breaking the loop. So this break right here has nothing to do with the if. It has everything to do with being inside of this for loop. So this break will pop me out of whatever loop I'm in. So here this for loop is covering all this code and repeating all this code. This break here pops me out of this for loop and ends the program. But I'm going to rewrite this. So just to show you how a switch works, I'm going to comment this one out. So in addition to this if-else style in Go, there's also something called a switch. And it's set up slightly differently, even though it does the same job, which is to allow you to branch to different places based on a condition. So what I'm going to switch, so the way I read this is I'm going to switch on the choice. In the case that the choice was 0, so that's what that kind of means. In the case that the choice was 0, then I will print, thanks for playing. And then break, which again breaks the nearest loop. case the choice was 1, so I'm switching on choice. In the case that I got a choice of 1, go play rock, scissors, paper. I don't have that option yet, but notice, by the way, I don't break after case 1 because I don't want the whole program to end. I want to go play rock, scissors, paper, and then I want the program to continue, which is what will happen. In the case, the choice was 2. I'm going to go play number guesser. And then with the switch, everything else is called default. So default means nothing else matched. So whatever they typed as their choice, it wasn't a 0, it wasn't a 1, it wasn't a 2, it was something else. And I'm going to do the same thing I would have done with the if statement, which is whatever you typed is not a valid choice. That switch that I just wrote works exactly the same as the if. You pick the one that you like best for that situation. I personally don't use switches a lot, other than when I'm teaching, but that's just a personal preference. If you like the way these look and they make sense to you, then use them whenever you want to and whenever they solve the problem. But I want to show you that that switch does the same job as this if. They do exactly the same thing. It's just a matter of which one I chose to code with. For our example, I think I'm going to stick with the switch version of this, so I'm going to delete this and keep the switch one. And then I'm going to go run the program and make sure that it does continue, and that when I type a 0, it quits. So 1 doesn't do anything because I didn't make it. 2 doesn't do anything. By the way, if I type a 3, 3 is not a valid choice because I do have code to handle that. If I didn't type 0, 1, or 2, they get a not a valid choice output. And then last time when I type 0, that should find the break. It's going to say thanks for playing. It's going to find the break out of the loop. And I would have wanted it to end the program, which it didn't do, which I'm disappointed about, which it should have done. Bummer. Well, okay, so yes, break. I'm guessing that break doesn't break the loop, even though it oughta. We'll worry about that in a second. I'm going to Control-C, and we'll fix that problem here in just a second. I may need to use a different kind of loop for that. To get that to work. I thought the break would have broken the nearest loop and go, but anyway. Oh yeah, I can do that. Good point. Let's just exit the program with a command. By the way, so good point. By the way, everybody, when I did that, my Atom is set up to automatically touch up import, so you need to import OS to get that, along with funct. Good point. Let's just go with that. I just need to test the 0. Okay, so there's my thanks for playing. Thank you for the fix. Okay, so let's make case 1 and case 2 go somewhere. So on your project, what you're going to want to do is have functions that you can go to from the main part of your program. So what you want to do is, instead of having a comment there, you want to call a function, say rock, scissors, paper, that jumps to another function that then takes control of running that game for you. Now this part I'm not going to implement it fully. But this is kind of like a main just for the rock, scissors, paper part of the program. So one way to think about what you should do here is whatever you did in main on the rock, scissors, paper lab should be what you do in the rock, scissors, paper function for project 2. So the way I picture this in my head is that main controls the whole program, and then rock, scissors, paper controls just the rock, scissors, paper part of the program. It's like its own little subunit of main just for that part of the program. And I'm going to do the same thing for the number guesser. So I'll make a little function for the number guesser that will take control of that part of the program. And then from there, that's where all of the activities that are involved in running the number guesser game would happen. What you can't see here, by the way, it's hard to see, this for loop, when it kicks out, when it branches to rock, scissors, paper, when rock, scissors, paper is done, it actually sort of comes back to this for loop. So when rock, scissors, paper is done, this for loop gets control back, and it's allowed to then repeat the menu, and then kick out to rock, scissors, paper, come back, kick out to number guesser, come back, until finally they type a 0 where it doesn't kick out anywhere, it just exits the program. You can't really see that, you just have to develop a feel for the fact that it works that way. But because I'm in this loop, when they pick rock, scissors, paper, I kick out to rock, scissors, paper, and then come back. And then kick out to number guesser and come back. At least that's how I picture it. Okay, so I'm going to add a menu option here, and then I'm going to go do some experiments. So I'm going to enhance my menu by adding an option number 3. Where I'm going to just experiment with some loops as a part of this larger program, just because I want to keep all the code for today in one place. But also then we'll see sort of how do I add additional functionality in. Okay, so I added an option 3, so I come down to this switch, and I'm going to add a case 3, because now I have 3 as another option. And then I will create a function to take control temporarily of running some experiments for me. Okay, so same routine as before. I'm going to put the experiments right at the top. The order that these things are in does not matter. The one thing to keep track of, though, is that notice that the block for experiments, notice that the block for experiments opens and closes completely separate from the block for rock, scissors, paper, which is completely separate from the block for number guesser, which is completely separate from the block for main. So every one of these functions needs to be completely separate from the rest, ideally with a blank line in between them. You don't want them getting inside of each other. So I don't want something like this. I don't want something like this. So notice if you look at the blue underlying curly braces, right now rock, scissors, paper is completely inside of experiments, and that you don't want. So make sure, I'm going to Control Z to undo that. Make sure that experiments is completely separate from rock, scissors, paper, which is completely separate from number guesser, which is completely separate from main. If you're in doubt, you can use the folding feature of Atom. So you come over here to the left margin and there's these little down pointing arrows. So you can use the folding feature, and that will kind of give you a sense of whether or not they're all separate from each other, because if the folding doesn't work right, then you've got something mixed inside of something else. I'm going to leave those folded actually. The way you unfold them is click now the side facing arrow. I don't really need any of that stuff unfolded, I just want to play with some experiments. Now I'm also at the same time trying to give you a few hints about how you might do the project. So I'm not going to write all my code in here. I'm just going to use this function to call other functions. So this is the function that controls my variety of experiments. So the first experiment I'm going to do is a forever loop. And I'm going to write a function that's called forever loop, which I hope also sort of helps remind you what's going on here. So add forever loop. So I'm going to implement that function forever loop. Notice that forever loops, curly braces, are completely separate, open and closed, from experiments forever loop. Every function has to be completely separate from the others. So forever loop the important thing to remember about these is that you have to break them manually, typically. So we're going to set up and do that. I'm actually going to I'm going to use 3 different loops, 3 different techniques for solving the same problem. So what I want is, yeah, we'll just do it in tens. So I'm going to do a counter that only spits out tens. On every 10th tick. And by tick I just mean repetition. In fact, I'll just say it that way. So I want a counter that goes 10, 20, 30, without all the numbers in between. So I'm going to write a forever loop for that. And I want to say that it should stop when it reaches 100. So how do we do that? Let's make a counter. It's going to start at 0. So the way we do this is we check the counter to see when it's an even multiple of 10. In fact, let's start the counter at 1 instead. So to check even multiples of 10, I don't know if you guys remember this, but the way you do that is with mod. So if the counter mod 10 equals 0, counter is an even multiple of 10. That's how you test for that in code. So this means that this is only going to hit when counter is 10, and then when it's 20, only on even multiples of 10. So if the counter is 10, I'm going to print it out. Maybe with a couple of dots behind it. I'm not going to put a new line there, by the way. And then I'm going to count up the counter. So the counter is going to count up, that's all in the for loop. So every time we repeat this process, it's going to check the counter to see if it's an even multiple of 10, and if it is, it's going to print it out with 2 dots behind it. The 2 dots are just there because I thought it would look cooler that way. Then not it prints out the counter, it's going to count it up by 1, which is incrementing. We call that incrementing. I.e. add 1 to it. Okay, so let's trace what the program's going to do and then run it. So I'm going to unfold main and try to explain how this is all going to happen. So here's main. So when I run the program, main is the first thing that happens. It's going to print this message 1 time. Let's play some games. And then enter into a loop and begin repeating this menu. So it's going to show those 3 or 4 options now. I'm going to pick option number 3 when it asks me for my choice. That's in the switch. When I switch on that choice of 3, it's going to take me to experiments. So it's going to jump up to experiments. And when it gets to experiments, it's going to discover, oh, I'm supposed to go do this forever loop function. So now it's going to jump up to the forever loop. It's going to print out a message and then print out another message, start up a counter at 1, and then start repeating something. I already saw, by the way, that I have a problem, but let's just let it happen. This one's got a problem. It's going to count, and then on every 10, it's going to print out the value of the counter at every even multiple of 10. In theory, when that's done, it's going to find its way back here. So it left from here, jumped out to experiments. But when it's done, it's going to come back, and now this loop will continue executing. That's hard to see. It takes some getting used to. Did anyone see any? Well, don't you run this yet? Wait until I run it and you see that there's a massive problem, and then we will fix that. Alright, so here's the menu. I'm going to pick 3. It's going to cause it to branch out to my experiments function, and then that's going to cause it to go to forever loop, and then watch what happens. Control C. Control C. If you notice, by the way, these are even multiples of 10. The problem is that's a forever loop doing that. And a forever loop, unless you cause this forever loop to stop somehow, it will never stop. So I need to cause it to stop. So the way I'm going to do that is probably, where do I want to do it? Is it after I count up? Yeah. So probably right here, every time I count up the counter, I want to check to see if I should stop. So I'm going to use another if here for that. So I use one if to say, should I print the counter on an even multiple of 10, and then I increment the counter to grow it by 1, and then I'm going to say if the counter is greater than 100, then I've gone far enough. So once the counter becomes greater than 100, I will break this loop. Okay, so this check here allows us to break or stop the loop when we want. And when we want to do that is when the counter has grown to be greater than 100. The break part is the thing that actually does the breaking. So now when we run it and we pick option 3, we should see 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So I'm going to pick 3. So there's 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. It would be nice if I had a line break in there, so I'll probably go add that. But it stopped at 100 because I wrote code to make it stop at 100.
In addition to doing this break, let's see. Yeah, actually, where do I want to do that at? I think right here, perhaps. The thing I'm sort of struggling with right now is trying to decide. I do not like that the menu is right there, so I need to put some line breaks in to separate those things out. And I think where I'm going to put it is maybe right after this forever loop. I'm going to put a line break. So to run the forever loop part of the program, we'll print a line break, a new line, and then whatever else happens after. So that's one kind of loop. Now we're going to solve the same problem, but with a second kind of loop. So the second one I'm going to call conditional loop, and then I'll show you sort of the difference. So I'm going to run the forever loop version, and then I'm going to make a new function, so pay attention to where I'm putting that. Remember, all this code will be posted in the files section. So completely separate from the forever loop, completely separate from experiments, I'm going to set up a new function called conditional loop. And I'm going to do the same problem, but with a different kind of loop. So set up a counter equal to 1, and then you'll notice the difference. So this second kind of loop, I'm calling it a conditional loop. And you'll notice that there's something here now. So the difference in this kind of loop is that this loop is designed to continue as long as this condition is being met. For those of you who have had programming in other languages, we call this a while loop. But in the Go language, we always use for to repeat things. So the way I read this, though, is as long as counter is less than or equal to 100, keep doing something. So what I want to do is, if it's an even multiple of 10, then I'm going to print it. And then whether or not I print it, I'm going to increment the counter. Let me expand for, no, that's too much to look at. So one thing to notice here is I no longer have to do anything I no longer have to break the loop in the loop. The way I would say it, it's not really technical terms, but the reason why I no longer have to break the loop here, like I did in the forever loop function, is because the loop owns the condition now. So the loop is already aware of the fact that as long as a condition is being met, it's supposed to keep going. So I like this loop better than the forever loop for this kind of a problem because it's cleaner looking. It's a little bit prettier code, and it's less if statements on the inside of it. It's just looks more efficient as code. I forgot to, after that, down here in experiments, I don't want to get too much of that off the screen. I'm going to keep putting a new line character like that. So let's go run it. We should see the same stuff twice. I'll quit. Let me clear my screen. Okay, so I'm going to pick number 3. Now it's going to kick out to experiments. It's going to run the forever loop part and then put a new line character and then run the conditional loop part put out a new line character, and then it will go back to where it left off in the menu loop. So there's the forever loop working, there's the conditional loop working, and then back to the menu. I'll quit. So kind of the same thing as I was saying between a switch. So here's the forever loop. And the main difference here is that you have to do the breaking check inside the loop. That's the forever loop. If you look at the conditional loop, you don't have to do the breaking check inside the loop because the loop owns the condition. So I put the condition here. Notice the logic for it is slightly different, but it's the same meaning, right? As soon as this reaches 101, that causes it to break. In this case, as soon as it reaches 101, it's no longer meeting the condition and the loop's going to quit. Okay. Remember, I'm going to post this code, so if you're not getting it all, don't worry too much about that, because I'm kind of watching the clock here and probably coming up on the end of my time. Okay, so one more. What I call a counting loop. This loop, I think, is the one that looks the most difficult to people at first, but I bet you that once you get comfortable with it, you'll use this one more than you use the others. But just keep in mind that this is I'm just solving the same problem 3 different ways, and at the end of the day, your job is to solve the problem. How you solved it is your business. So now I'm going to solve the same problem with a counting loop. So we'll set up another function. I'm making sure that it's completely separate from the others. Alright, so this is how this one works. So I think a lot of us like this kind of loop a lot because it's so compressed. It's doing all the same jobs, it's just sort of doing them in a compressed fashion. So everything that the loop needs is now owned by the loop. It sets up its own counter. It has a condition that tells it whether or not it should repeat itself. And it increases its own counter, it increments its own counter. So the counting loop means that the loop kind of owns all of the controls of the loop, and all you have to do in the loop then is do what you were wanting the loop to help you do in the first place, which in this case is print out multiples of 10. So we'll just compare it real quick. I'm going to take this comment out because it's making it hard to look at. So there's the conditional loop. So notice for the conditional loop, I have to set up a counter outside the loop. Then I have the condition that tells the loop whether or not it should repeat itself. Then what I want the loop to do, which is print out multiples of 10, and then finally incrementing the counter, which I had to do as a separate step in the loop. So if you look at the counting loop, all of that loop control is part of the loop itself. Setting up the counter as opposed to before the loop, it's now in the loop. These things have to happen in this order, by the way. The condition that says whether or not the loop continues itself, and then finally the incrementing, the thing that increases the value of the counter and advances it toward its goal of being greater than 100. So a lot of us like this loop because it's just sort of the cleanest way to do this kind of work. Even though at at first, having three things like that can be confusing, and which goes where, and that just takes practice. Let's make sure it works. So I'm going to pick number 3. So there's the forever loop solving the problem, there's the conditional loop solving the problem, and there's the counting loop solving the problem. So I wanted you to see that they all solve the problem ultimately. It's just 3 different ways of doing it. You will see in time though that these different loops have places where they work better than others, and I'll point those out to you when we encounter them. So, like a lot of times for the rest of the semester, you're going to see me referencing a counting loop because it works so well for some kinds of problems. And then my exit, which still works. Okay, that's most of my time. Sorry about the audio issues. I still have to figure out in my house where's the best place to broadcast from so that I don't have the issues. This morning's class, which is in my same setup, didn't make any comments about the sound, but maybe they were just too sleepy and were gutting it out. So I'm going to try to move it, and it may be the table isn't helping. It's a very hard table. I don't know. Maybe it's reflecting the sound of my fan. I will work on that. Anyway, on Thursday at 2 o'clock, we will work through Lab 9 together. Where you'll see me, maybe I'll use the 3 different kind of loops just to show you that we can solve those 3 problems with 3 different kinds of loops. On tomorrow at 10, I will be online only to answer questions, so I won't be doing any content, but if you have questions and you want to come in and ask me live, you can do that tomorrow starting at 10 a.m., and I'll just sit there for a while until I'm not getting any questions. And that's about it. So I'm going to sit here now for a few minutes, and I will field your questions if you have them. While I'm doing that, I'm going to post today's example to the files section of my website while I'm waiting. Okay, so mar31.go is in the file section of my website, so everything that I did today is in there. didn't have to on project 2, but it's more fun to play with if you have a for loop in project 2. So it wasn't required. Oh no, it does. It does. I'm wrong. Let me adjust my view and I'll show you. Let me put the browser back in view. So yes, down here on number 5, uses a loop to repeat the program. So yes, you do in fact want to have a loop for project 2. If you've already sent it, you can update it and send a new one. Better to do a loop. It's rare that you will see people call their own main. With more complex programs, funny things can happen. So at least have a shot at using a loop instead of calling your main menu and see if you can get that to work, and that would be a better version of it. If you can't get it to work, then just leave things as they are. But if you can get a loop to work instead of calling your main, that's a better way to do it. And it will save you trouble when you get yourself into more complicated problems. I want to make sure I understand the... Hold on, my wife's phone's ringing, so sorry about that. Oh, that's my phone? Oh, will you answer it, please? It's probably those people. Okay, sorry. Notes on it. You can change it if you like. I don't know that I understand for sure what you mean by notes on it. But you certainly can change what you have and submit a new one. Sure. You mean so feedback on the current version of it, you mean? Yeah, we did do it a month ago. I'll put it in my inbox and then I'll email you. So what I'll do is I'll drag the current version to my inbox and I'll send you a couple notes on how that one's working. And then if you can get a loop version working, that would be better. But in fact, the project has it as a requirement, so it probably would pull a deduction if you don't get a loop in there. But let me put your current submission in my inbox, and then I can send you notes on it, so that at least you know the parts that are presently perfect don't have to be touched. Where'd it go? Where did it go? so, hold on, there it is. Okay, so I moved it to my inbox, so I'll send you an email with notes about the rest of the program, and then you can probably get to work on the loop part without sort of breaking other stuff, and then I'll give you notes about the other stuff. Okay, anybody else? Okay, thank you all for being here. We'll be on at 10 a.m. in the morning if you want to just drop in and ask a question. You can email me questions, which if it's something that I think a lot of people would benefit from, I might share it on the stream. I won't use your name behind it or anything, but I might share the question if I think it can benefit other people. And then I'll be back here for you guys at 2. Hopefully the sound got a little bit better in this room, which means that I need to move my setup into this room, where it's just a tad less echoey. But we don't have a lot of furniture in this house, so we don't have many rooms that aren't very echoey, so I just need to work on that. So thanks for your patience. Anyway, have a good day, and I'll see you possibly in the morning, and I'll also be back here at 2 for your class on Thursday. Yes, thank you, David. Oh, it's a good point. I sent everyone a link to Discord, so that's another channel where we can all help each other. So don't be shy about answering questions in there and asking, and I'll look on occasion, but if you think you can help someone, jump in and see if you can help them. So thank you, that's a good point. We do have Discord. I am monitoring it, and everyone should have gotten a link to the Butte College email to get signed up for that. Okay, see everybody later. Thanks.